Hello, my name is Chris. Welcome to my dissertation presentation. The subject is the Websocket protocol a viable alternative to HTTP polling for bidirectional communication in the web browser. It's primarily a software project, but it's quite heavy on research as well. Okay. Quick overview. Start by giving a bit of a background on the HTTP protocol, problem with it for modern current chat applications. I'll then talk a bit about WebSockets, and then demonstrate a chat application that I built using the new WebSocket protocol, and the problems I had in development of that chat application and future improvements. And then the second piece of software I developed was the benchmarking software, which I'll demonstrate afterwards and discuss my results. Okay, so a bit of background. So Tim Berners-Lee invented the World Wide Web in 1989. Three primary protocols are Hypertext Markup Language, Hypertext Transport Protocol, and the Uniform Resource Locators. The three of those combined make up the web as we know it, combined with the get and post HTTP methods or verbs. The web uses the client-server paradigm, where only communication between a client and a server can be initiated by the client. There's never ever been a way for the server to initiate communication, which previously could only be done on desktop applications, where clients could communicate with other clients and servers in a bidirectional, fully duplex way, using low-level network layer protocols like socket protocols. In the early 2000s, it was the advent of Web 2.0, where traditionally desktop application solutions needed to be moved to the internet, and there needed to be a way to mimic real-time communication in the web browser, where previously it was only suitable for static data information web pages. So methods using asynchronous JavaScript and XML were developed. Comment-based techniques were developed using JavaScript to mimic real-time communication in the web browsers. The three main ones are, or the first one rather, was HTTP polling. This is where the client polls a server at regular predefined intervals to check if there's new data to be retrieved on the server. This is a wasteful way of checking for new data, and it's never going to be real time. There's a lot of network throughput, for example, and potentially, and in fact, a lot of empty responses will come back where there's actually no updated data. Okay, next one is HTTP long polling. This is where you'll send a HTTP request to the server, and the server will actually hold on to the response or the last frame of the response until it gets new data, and then responds to the client. When the client gets that response, it immediately fires a request back to the server, and the server again will hold on to that response until it gets new data. So it's a slight progression there, but ultimately it's still not reliable for true real-time, fully duplex communication. And then where we're at now, the HTTP protocol, or up until 2013, 2014 rather, is streaming. It's where the client sends a request, the HTTP request to the server. It holds on to it indefinitely, and it never returns the last frame of the response with the end stream flag to tell the client that the communication has ended. It just holds on to it and just constantly streams data. Okay. And then so the problem with the protocol is that it's a minimum of 48 bytes, and typically a lot more data than that, because you have header data, cookie data, especially in web browsers, and then you have the problem of data storage on web servers. Is the whole point that when you poll the server then has to query a database and subsequently process that data and return it to the server. And just a reminder of the HTTP handshake, if you didn't already know, is that client sends a synchronization frame to the server responds with a synchronization acknowledge frame, and then the client acknowledges the receipt of that response, and then data can be transferred. This is all really cumbersome, wasteful way of sending bloated data that's not really useful, and it has to be done. That three-way handshake has to be done every single time. You just want to poll new data, which is it's a high amount of latency and high amounts of network throughput. Okay, so a typical HTTP handshake requests for data using just a typical Chrome browser. Just if you do a query for the CNN, just the CNN home homepage on Chrome, it's 2,800 bytes for the request, including all your cookie data and largely useless header data. And then typical response, 200 OKs, 355 bytes. So it's a lot of data that's being passed all the time. Okay, so it kind of all adds up to high latency. So what's the alternative? Like, what if the HTTP handshake wasn't necessary? What if it only consisted of a base 6 bytes instead of 48 bytes for a two-way handshake instead of a three-way handshake? What if we didn't have to send any header data at all, and no cookie data that doesn't really get used a lot anyway? And what if we didn't have to store data? Why couldn't, when the server gets the data, why can't we just send it out straight away? Why does it have to save it? Okay, and then so the problem with web-based chat applications, three main ones I've sort of picked on are message retention. And in itself, it's kind of like it's kind of a good thing. Like if you're not available to receive messages on Facebook or WhatsApp, it's kind of a useful thing being able to come back to it later and see your message history or new messages that you haven't read. But don't forget that all that data is getting stored, and it's for a lot of these companies, these free companies, that they're using that data to sell to third parties. And for a lot of people it doesn't really matter, but why can't there be an option to not have to deal with that? And in the future, you never know what could come from your data being used in this way. So free isn't really free. It's free in exchange for your personal information and stuff. And if you really care about stuff like that, then it's a really quite an important issue, potentially in the future. Okay, so quick introduction to the Websocket protocol. It's the alternative to HTTP polling. It was invented in 2011 by the Internet Engineering Task Force. Became fully cross-browser compatible in 2013, except for the Opera Mini web browser, their mobile version of the web browser, which relies a lot of the request responses run through their actual internal servers, which messes with the WebSocket protocol. And for the first time, October-November of 2013, Oracle supported WebSockets on the back end using their server endpoint framework. So for the first time, using HTML5 and Java, you could, at the end of 2013, you could actually do fully bi-directional communication with WebSockets. Okay, so the WebSocket protocol, it only requires one two-way handshake. So when the client requests, sends a request to a server, it contains a header, an upgrade header to a WebSocket header, and if the server has a technology that supports WebSockets, it will reply with a 101 OK, and immediately the connection is upgraded to a WebSocket connection. Extremely low latency data transmission. This is because after that initial handshake, two-way handshake, no header data is transferred anymore, or cookie data. It's literally just messages or bit data that is streamed in either direction at any time. Fundamentally, it's an event-driven protocol, and the APIs on either end are event-driven. They use event handler methods that are triggered when either side sends a message, or either side closes the connection, for example, or there's an error on either side. Okay, so the first piece of software that I developed for this project was Socket.chat. Its primary focus is on simple, private, and secure chat rooms, old school chat rooms, style chat rooms. It's one-click room generation, responsive cross-platform integration, completely anonymous usage, fully featured chat service. So all the kind of chat room specific features you can find on most of the big services at the moment online. This does. Okay, so if any of you are connected to the internet now, feel free to go to this link and you can play around with it and stuff. I have a video. Okay, so landing page, you can create a chat room, give it any name, any alphanumeric or spaces, names that you want. You'll immediately be prompted to put in your username. Alternatively, if you just want to quickly get in a room, you don't really care about giving it a name, you can just click the randomize button and it will generate a random room name for you. Or you don't even have to go to the website at all. You can just put in any alphanumeric spaces name for a room. This makes it extremely private because there's no way anyone is going to guess your room name if you want it to be secure. Just a bit of information. I used version control for the software development. I used GitHub to host it online so that it could be viewed publicly. I did 2 open invites to 2 online communities to get qualitative feedback from a technical standpoint and just from a general user standpoint. And this was what I used to build after the first iteration of the software. It's what I used to build general core features that I've introduced. So it supports streaming. It currently supports 2 at the moment, but I'll expand that to, and eventually I'd like to make it customizable from a user endpoint. The next is notifications. Okay, so there's audible notifications of new messages and chat room messages, private messages and chat room messages, and also there's tabular notifications. So you don't have to be in the room the whole time to know to look out for new messages. If you're doing something else, then it will notify you in an audible way, and also you'll be able to see it on the tab. You've got a new message. Okay, responsive. So as long as your whatever device you use is a modern has a modern web browser, the UI will dynamically respond and resize depending on the size of your screen. Another crucial part is the security. The application doesn't store any personal information in your cookie data, and in future it won't even store your JSession ID because I'm going to move away from Java support on the back end, which I'll talk a bit more about in a moment. It uses public key infrastructure, and a strong RSA-based bit key, 2048 length. It's a length which, if you know anything about PKI, it would take the combined computing power of the entire world at least 100 years to be able to crack this kind of encryption, at which point the information that it was encrypting becomes useless. Okay, sorry. So the first version of Socket.chat went out on, it was actually in July in the summer of July, but I didn't actually start recording usage until late September. And so this records users that have input their username and actually joined the room. The spike in January, that correlates to, I believe that's the second time I invited these two subreddit groups to review and give feedback on the software. So that's kind of like where the spike is, I think. Okay, so two main problems, I think. The first ones were general bugs and feature requests, a lot of which came out of the invitation of these public groups to review. They did really help me, and I found a lot of bugs that I could fix and stuff. The second one, which turned out to be, and it was totally unexpected, but it turned out to be the biggest problem, and it's almost ground this project to a halt, was actually just switching to the secure versions of both protocols, the HTTP secure and WebSocket secure protocols. I was using the open version of the protocols throughout the entire 8 to 9 month period of developing, because it was easy just to swap from my local development environment to the remote environment easily and do testing it's easy to do that, and I figured that like at the end it would be very easy just to switch. It's just a configuration thing on the Apache server. Apache PKI is just public and private keys, just a configuration issue. But it turns out that the way I had set up, because I used Java on the back end, and Java runs, and the way I had it running was on the Tomcat server container that sat behind the Apache server. And the problem with Apache is that this is a relatively new technology, especially the secure version of the protocol, and it's the issue was that the Apache was not able to reverse proxy the secure version of the WebSocket messages internally, locally to the Tomcat container. So try and get into a room and it just wouldn't connect. The solution to this, and I did this in about 4 days, it's a couple of months ago now, but there was an intense period where I realised, crap, I'm going to have to rewrite the server software in a different technology that I'd never used before. But I ended up using Node.js, their WebSocket API, and I rewrote the WebSocket aspect of the server, so it now runs on its own, not in a Tomcat container and not behind Apache, but alongside Apache, on port 3000. And doing that enabled me to, having to rewrite the server code, it gave me the opportunity actually to do a lot of refactoring. So I managed to improve the code, make it a lot more streamlined. And in case you weren't aware of Node.js, it's very lightweight, it's very modular. You just add in packages that you want to use for different technologies. It's efficient, extremely efficient at high concurrency. So high concurrency is where it's pounded by a lot of requests simultaneously. It's very good for that. And it uses the JavaScript V8 engine, which is the latest JavaScript programming language. So now I'm programming the front-end client in JavaScript and the back-end server in the same programming language and using the same API, event-driven API. So it's being able to use the same programming on the front end and back end is just a lot better than using Java in Tomcat. Okay, so future improvements. I need to make it scalable. any large, anything that you want to be obviously be large scale. A lot of users global these days need to be obviously scalable. So I'd like to implement load balancing with cluster servers. Obviously multi-language support. Make it globally accessible. If I could have at least one server on in all the inhabitable continents in the world, I'd be very happy. And in terms of features, I'd like to add voice over IP. So when you enter a room, I'd like it so that you might rely on a plugin of some kind, but once you've installed that plugin, as soon as you join a room, immediately you'll be able to hear everyone else inside the room as well. So I'd like to do that. Okay, so the next part of the software. Okay, separate piece of software is the benchmarking. So this is actually comparing the HTTP protocol versus the Websocket protocol. So I tested two main tests were request response and concurrency. So test one, retrieve the contents of 10 files, and test two, retrieve 3,000 concurrent messages. I'll come back to that concurrent. So just briefly. Client request, sends a request to the server. Can you give me the contents of file X? So there are 10 files. They all have to be different and different bit types. Otherwise, I had some issues with caching with Apache initially, because this software is still written in Java, which sits behind Apache, and Apache has a tendency, usually it's a great thing that it will cache, especially on the intermediary servers, they cache data so that you don't traverse all the intermediary network devices to get the new data. But for this test, it wasn't a good thing, obviously. So repeat that 10 times, and then, so for concurrency, so obviously just fire off as many requests as you can to the server, and then record how long it takes to get all 3,000 responses back. Demo.
2 minutes to do this bit.
Okay. Okay, so I'll point out now quickly just while it's going that the fundamental issue with HTTP versus WebSockets is that HTTP is not inherently concurrent. When you send a HTTP request, it has to wait for the response, otherwise it will never know that it gets it. Whereas WebSockets, because it's event-driven, you can just fire off however many requests you like at the same time, and you don't need to wait for to count each individual response, because when a response is returned, it will fire off the event handler. It will fire off the event handler. It will fire off the event handler, and it doesn't need to keep track of each request. So just to briefly go over that part. Concurrency, HTTP took 10.459 seconds, whereas WebSockets only took 0.450 seconds. So this is 3,000 requests. And it achieved this because, as I just mentioned, WebSockets didn't have to, in an iterative way, fire off the requests and then wait for the response, where in traditional HTTP, you have to do that, otherwise you'll never know that you got the response. Request response. I wasn't actually expecting this, and potentially it's possibly to do with the setup, but WebSockets was actually slightly slower. So it's something I wasn't expecting. It's actually 81% faster on HTTP.
Audience questions?
What was he talking about?
Your chat room, is there a way to moderate it?
No. The idea and the kind of community that I'm serving is the one that's it's kind of like the anonymous crowd, the people that don't want to be, don't want people knowing perhaps that they've got this small community, to chat privately, and that's why I made it. There's a large focus on making room generation, really bespoke. So you could create these ridiculously long room names that no one else will be able to, work out. So you will have that privacy, and you won't have to worry about moderating a room. But potentially, I mean, if it got popular and it was used for, mainstream type, things like football or anything, so potentially in future, moderation could be something I'd look at. Yeah. Any more questions?
Currently, when adding current VoIP feeds be like a bit.
Say again, sir.
Like when adding VoIP to it,
Yeah.
would it be a bit chaotic?
Yeah.
Is everyone talking at once?
I think the way because as far as I'm aware, HTML5 doesn't natively support VoIP at the moment. I think all the current solutions like Skype and Facebook they rely on installing plugins. I haven't looked too far into the actual development detail of it, but I think if I could rely on just a plugin that will install once, I think that could, it's potential. Get away with that, potentially start with until the technologies progress, so it's natively supported in web browsers, which will happen. Will happen definitely.
On your chat, because you have like Facebook has a scene, so you can see that people have read your message.
Could do, yeah. I've got you can do, yeah. And that will work in a similar way that I've got auto AFK. I didn't demonstrate it. Didn't demonstrate it in that video, but the auto AFK works. And if you don't click in the browser or do any typing or anything, it does auto AFK. It gives you a little marker. So using a similar sort of approach, I could do it so that if the person doesn't click in perhaps or doesn't type, they haven't read it. But it's kind of like, it's not a reliable way because people just sit back and just watch. So, I mean, potentially, perhaps more private messaging. So I have implemented private messaging, so it's certainly something to do.
Considered online safety.
Do you mean in terms of regulation? Or?
Regulation. Safety of certain portions of society.
Yeah, I have done, and no, it doesn't. There are no issues there because of the fact I'm not storing personal data in both cookie form, and I don't have to manage or moderate any of their personal data because they haven't registered or logged into the service. I'm not storing any of their personal data on the servers or even locally on their own devices. So it kind of gets around that issue.
Online abuse or anything like that?
Do you mean in terms of bullying or?
Bullying,
Yeah. There's only I feel like there's only so much I can do as the system, the company or the developer of the software. It has to come a point where it just becomes a platform that people use and they have to use it responsibly, like any other platform. But I guess it's comes back to the whole moderation thing. Like if there is a popular use for it and they become name categories and talking points, the public get together. That's how to get moderation.
Anybody else?
I was just going to follow on from the saying there's like legal activity going on and discussing things there.
Yeah. I mean, it's kind of like one of the fundamental things was that we would know that GCHQ and the NSA, we would know about any of these issues if it wasn't for people like Edward Snowden having a platform to notify the rest of the world about these issues that will for our benefit, And I feel like platforms like this, they'll serve a very, very small portion of the world's community, online users. But it has systems like this do have a very important use.
Thanks.